Hello and welcome to Elite's Geospatial, and today is 1st of November 2020, and I welcome you to class. Today we'll be performing a supervised classification. Our study area will be Amac, and then I am SHAMAKI RIMAMFENTEN. So today this is what we're going to be happening. Okay, the software we require to use, we'll be using ERDAS Imaging 2022 alongside Google Earth, which will help us to put together the coordinates and then allow us to see what is actually available on the Earth surface with the help of the ERDAS Imaging and Google Earth. And we'll be using Excel to pick out sample coordinates for the portion and each class we're going to be using. And then finally, this is what we'll be doing in this video. We'll be looking at how to download Landsat 8 oil imagery. We'll be doing layer stacking. We'll perform histogram equalization, and then we'll go to learn how to subset, then how to train pixels, and finally how to perform supervised classification. Alright, so without any further ado, so that's what we'll be doing today. But before we go on, I have a special announcement to make. So quickly I would like to beg your pardon to take some few minutes and look at my channel. If you come across this video, please do not just walk away, but try to also subscribe, like, share these videos for others to also see. This is the little we have. All you need to do is to come in and then click on subscribe, and then like any of the video and share it to others so that they could also benefit from what you are benefiting from. So without any further ado, let's get right into the video. So we're going to be looking at how to download Landsat imagery. Alright, basically for you to download Landsat imagery, you need to go to earthexplorer.usgs.gov. Alright, so once you have the site and you click enter, you need a fast internet, and I'm currently running on a slow internet, so that will delay us a little bit, but then I'll be pausing the video and coming back. Alright, so we have few criteria to look at here. We have the search criteria, we have the data set, we have additional criteria, and then results. So basically under the search criteria we have the geocoder and then the KML shapefile upload. These are the two major input into this website. But then first, before you could do anything, you have to have logged in. If you don't have an account, I have a video on how to create an account with USGS. I'll put the link to the video on this on the description below. So we're going to be using the geocoder, because under the geocoder you have three options. We have the future GNIS, we have the address and place, and we have the path and role. So if you know the path and role of the location you intend to download, all you need to do is to select and then put in your path and your role. But if you don't know the path and role of the location you're working on, so you can use address and place. So in this case, I'm going to put in Abuja, because that's our study area. Amac is the Abuja Municipal Area Council. Alright, so I'm going to put in Abuja. So you'll see Abuja Federal Capital. So you just click on it. So it's going to make a highlight here. So they have a highlight. So that's all you need, because this is currently in Amac. You could see the boundary of the administrative boundary of Amac here already. So you know that this is actually inside Amac. So also down here, depending on the year you want to work on, Landsat 8 was launched in 2013. So from 2013 down to 2023. So any year you're looking for within this period, you can download Landsat 8. But if it is below 2013, then you have to go with the Landsat 7 enhanced thematic imager, that's ETM plus. Alright, so if it's below 96, you use Landsat 5, sorry, because Landsat 6 was launched and then it's vanished. So basically we have 9 Landsat as of the moment. Landsat 9 was launched in 2021, so but it's currently available. So the date you want, I will currently want just 2022, that's last year. So I'm going to put in a month range. I'm going to put in January 1st of 2022. Then they're asking me to what year. I'm going to put in 12, which is a month, and I'm putting 31st of December 2022. So my image should be within this time frame. Alright, so you could also select the land cover this thing you're looking for, but I don't even advise, so you don't even do anything there. So and then they're asking you like what level of the results should be displayed to you. You could select 5, 10, 12, 25, 50, 100, but depends on you. So basically, let's say we're selecting 25, and then we save the profile. So the next, we're going to data set. Now on data set, we're coming down to Landsat. So on Landsat, you get down to we have Landsat collection 2 level 3. It's a science product. We also have Landsat collection 2 US analysis ready data. We also have Landsat collection 2 level 2, and we have Landsat level 2 collection 2 level 2. Same thing, we have Landsat collection 2 DEM. Alright, so basically they also have a DEM data, so you could also download. And then what we're interested now is the Landsat. We're going to use collection 2 level 1. So I'm interested in Landsat 8 and Landsat 9. Alright, so we're going to just click on the results now, since Landsat 8 and 9 are selected. So we're waiting for results to display to us so that we could build on from there. Alright, so we have few numbers of results displayed to us at that 25. Okay, so now what you need to do, you have the footprint here, which shows you the extent of this this SWAT, because each SWAT in the Landsat is 85 kilometer by 85 kilometer. And then we have the show browse overlay. You overlay the Landsat imagery on this, and you see it's already overlaying. So if you zoom, you will see the Landsat on it. So we also have the metadata, the metadata information about the data. That's what meta means. So we're going to check on the data and look at what are the clouds cover and all that, so that we'll know whether we should use this very image or not. So basically it gives us every information of this. So but we have here telling us this is supposed to display the image. That's a preview of the image, and then we need to check for the land cloud cover, which is telling us currently the land and the scene cloud cover are 0.02%, which is a very clean Landsat imagery. Alright, so but then what we need to check is there's currently no browse. So what we need to check is what month is this image. Okay, we're currently December 29 of 2022. So I think this is ready to go. So we just click on download option. Note that if you are not signed in, you won't be able to see this download button active. So you have to be signed in for this download button to be active. So now that I am signed in, you see that it's already loading. So you come to product options, and then under product option you will see there's a Landsat collection 2 level 1 product bundle. It's a 1.15 gigabyte. So once I click on it, we'll be taken to another dialog waiting for it to pick up by my internet download. So once it is picked up, it's either going to be picked up by the IDM or it will be picking up by the browser, anyone. But now it has picked up by the IDM. So but most of the times once you start the download, it's going to tell you the resume capability is no. So what I basically do is I cancel this, go to the IDM, and then I resume it again. So most cases it resume with resume capability. So you see the resume capability is yes, but then you need to exercise patience while it download. So basically I'm going to come back to this video once the download is done. So stay tuned. So we have our file downloaded here. So this was the Landsat 8 we just downloaded, and I'm going to cut it and take it to a folder I created. I usually put all my work at C drive. So whenever I'm starting a new project, I create a new folder so that everything I do is in that same folder. So we're going to create a folder in C drive inside my work folder, and then we'll create a new folder, and here we're going to name it Amac. Alright, since we're working on Amac, right, so inside the Amac I'm going to create another folder, and then I'm going to put it data. So this way all our data are going to be inside. Alright, so I'm going to paste that Landsat image I downloaded. Alright, so we have the Landsat 8 downloaded here, and first you require either a zip, an extractor, either a 7-zip or a WinRAR. So here I have both WinRAR and a 7-zip. So if you right click on it, the best way to do this, some people will always double click, and then this is not the best way. The best way is to right click on it and go to extract, then you extract to that folder that is going to carry the name of the file you're having. So I'm just going to right click and then extract to the same folder, so that's going to create this output for me. So it's, you know, the difference that I've realized with this level 1 and level 2 is that level 1 is somehow has all the bands that I know of, as I'm still trying to venture into the level 2. Yeah, so the level 2, collection 2, sorry. So collection 2 don't have all the bands I'm seeing here, though I'm still trying to learn about it. But normally Landsat 8 has 10 band, or is it 11 band? The band 10 and band 11 are the thermal band, while the band 8 is the panchromatic band, band 9 and all that. So basically we've extracted this, and now the next is for us to, from our timetable here, we have been able to download Landsat 8, and then now we're moving to layer stack. But before layer stack is where we come into extract this file, which I just did. So if you have ERDAS imaging from version 2015, you can replicate exactly what I am doing. For myself, I'm using version 2022. Alright, so basically if you have it, you just search for your ERDAS and then you launch it. Alright, so mine is already launched. What we're going to be doing now is to go straight into the layer stack. So this are the same across from 2014 down to 2022. There's not really any change more, but then this is how we're going to see the interface as you enter. What we're going to be doing is we'll go to raster, then on raster we go to spectra. So click on raster. There's this drop down button you're seeing here, so that's where you're clicking. So you click on the drop down button and then you go to layer stack. So on layer stack now we have the input and the output file. The input is where you bring in this whole file we have extracted in there. So once you click on this, it brings you to here. So from here you edit, drop this down, and then you navigate to the folder that carries your file. So I'm going to navigate to previous folder, then from there I'm going to go to where our work is. So I'm navigating to Engineer Bola, which is on the same drive where all my works are. So I'm just going to go back. So we'll see Amac. This is Amac, so where our data are, and then our Landsat 8 is in here. So from here now, I'm just going to click once on band 1, and I'm going to OK. Then I'm going to click Add. Then I'll repeat this process for band 2, 3, 4, and 5, and 6, and 7, and I'll stop there. So band 3, add, band 4, add, band 5, add, band 6, add, and finally band 7, because what I'm trying to do is just to monitor the change basically in land use, basically like an urban sprout, urban expansion and all that. Alright, so I'm just going to click here for the output, and then I'm going to navigate to where I will be saving this. So we have Amac. So now I do my work based on accordingly. So I'm going to create another folder, and this folder will be layer stack. So if I'm going to do 50 layer stack, all of them will be inside here, so that if I send it to you as a client, you'll be able to know exactly what I am doing. So this layer stack is for 2022. I'm going to OK it, and then after that you just click on OK. Now this language called layer stack is the same thing as band combination on ArcGis and any other softwares. So if you do not understand what layer stack means, layer stack is just basically you're trying to combine the black and white bands so that it could give you colors. Alright, so layer stack on ERDAS imaging, band combination on ArcGis. So it's processing, and then once it's done, alright, so it's done. So you click dismiss here, and then you click close. So now to bring it in, once you click on file, you see it there, or you can also navigate to the folder and bring it in. So you click, and then it comes right in, and this time around it comes in a color format. So this is, I think this is a natural band. So I'm just quickly going to, you could see that this is Abuja, and then this is mostly the Amac area. That's the municipal. Alright, so if I come to spectra and I change the band, let's say I use band 6 and I use band 5 and I use band 1, you will see that the rivers, as the water body is out, and then vegetation is springing up, and then other. So depending on the band you'll be using, for different purposes. So now here we're going to do one thing which from our syllabus we have, is to perform histogram equalization. So that's what we're doing next. So still on that, you go to raster, and then this time around you're going to radiometric, and then on radiometric you go down to histogram equalization. Now the input is already there. What we need is the output. Alright, so I'm going to click on it and then navigate to the folder where I'll be saving this work. So we have Amac up here. So let me just quickly put this as histogram, or better still, let's create a folder and say radiometric, in case we decide to do more than radiometric correction. So okay it, and inside the radiometric I'm going to put 2022, which is the year we're studying, and the format is the IMG, that's the imaging image, sorry. Alright, so you click on OK and allow it to process as usual. So this also has finished, so you click dismiss and you click close. So let's remove this and bring in, or let's basically bring the other one. So go to file and then you still bring in the 2022. So you'll see the difference now. So I'm going to go to multispectra, that's where you change their bands. So let me use band 5, 4 and 1. 5, 4, 1. Yeah, so you'll see that there's this distinctive changes. Let's make this 6, 5 and 2. So you notice that there's now basically not much difference between the rivers. Okay, the river is now darker, so this blue is now our built up area, so it's more like it's distinct more than the previous image. That's the one we just layer stack. So if you look at this, you will check out some things, few things from it. So this can be interpreted more. Alright, so let's remove the other one. So next from here we're going to do is, from our syllabus, is to perform a subset. And this time around we're going to subset to fit only Amac. So this is the Amac image, sorry, the shapefile of Amac. Now why I bring it to ArcGis is so that I can show you something. Now if you view the attribute table of this file, that's the metadata, you will see that this image is in a projected coordinate system. So when you look at the information, you'll see that it's under projection UTM zone 32. Now, the image, the shapefile you're bringing in must also have the same coordinate system as the Landsat image. So this from the attribute is showing that it is on geographic coordinate system. So this will not be able to subsect if you're using ERDAS imaging. Then you can easily search on the search box in ArcGis for project, and then it's going to bring you options to project. So you can use this first option. In an instance whereby this shapefile don't have a spatial reference, you will use define projection, so that you define the projection you want it to be. But in this case, it has a projection. So once I bring in Amac, you'll see the current coordinate system it's on, and then you will now define the coordinate system you want. In this case, we're defining it to WGS 1984 UTM zone 32. So I'm going to OK, and then I'm going to select where I want it to be. So in this case, I'm going to take it to the folder of the Amac. So this time I'm going to name a new folder, and I'm going to call it subset. So on subset, I'm going to add this shapefile Amac. Then I'm going to save, and I'm going to OK. So it's projecting. So it has projected. So once done, we go back to ERDAS imaging. Now on ERDAS imaging, what we do now is to import that shapefile. We just transform the coordinate system into the projecting coordinate system. Now, there are easier way I can still go back to raster, or I just right click on this blank space. Here we're going to see open raster, we're going to see open vector, which the shapefile is under the categories of a vector. Or you open an area of interest. That's AOI. Alright, but then here we're interested in opening a shapefile. Alright, so I'm going to click on OK, and then I'm going to navigate to our folder now, the Amac. So inside Amac we have a subset, and then we have Amac. So once I click on OK, the Amac will come up. So you see that Amac is already in here. So with Amac in, now here's how we subsect on ERDAS imaging. You click on it, it turns yellow. So once it turns yellow, you go back to home, or better still, where you are, you just remain like this. So you see this this here that said paste from selected object. You click on it. So it's going to paste. Now when you see this line that is as if it's a hashing line, it means they are on the same coordinate system, and then this time around it's going to work. So once you've done that, you click on it once more. It has created an AOI, as an area of interest. So even if you remove this one now, we have an AOI which we can use to clip this image or subset it to this location. Mind you, if this, with this, if I remove this one now, you'll still see this, right? But this image, this AOI is not selected. If I go on to subsecting this image without clicking for this box to come out, it will not do. But then we are proceeding. So let's go to subsetting now. You go back to raster, and this time around you're going to subset and chip. So you click on it, and then you click create a subset image. Now your subset image the input is already there. We're trying to extract this from the 2022, the entire SWAT of 85 kilometer by 85 kilometer scene, and then the output now, that's where we're going. So we take it to our subset folder, and then we can still just name it 2022, or we just name it Amac 2022 for understanding purpose. Okay, now here is the next thing. If you just click on OK now, it's just going to create something, maybe this box. It's not really going to follow the pattern of the way Amac is. So what you do is you click on AOI, then this time around you check on the viewer. If you have this AOI exported, let's say I can export this AOI here that was created and then import it as AOI file. So definitely I have to save it because we're going to use it in future when we're classifying, because if you just classify, it's going to create an additional field for you. So I'm going to definitely save this AOI so that we'll use it in future. Alright, so you click on the viewer and you select OK. Now you can now proceed to say OK and wait for result. So our subset is done. So I'm going to click on dismiss and OK, and close, sorry. So I'm now going to export this AOI. Yes, I'm going to save it. So I'm going to save it in that same subset folder. So I'm going to save it as Amac AOI, because we have other AOIs that we use. So you save it so that you don't miss out. And so I'm going to remove this also because its job here is done. Then I'm going to file, and then I'm going to bring in the Amac 2022. So you can see that it has subsetted to this location. So you see, this is the Amac location that it has subsected to. So now let's go back to multispectra and make some changes to the band, because this is now a natural band. So let's take it back to 6.5.01 or 2, anyone is fine. Alright, so we have this. Let's make it 1 and see. Or better still, let's say 541. 541. Yes. So any band that fits in to what you're studying. So you also need to check out on band combination, like how you combine the band to serve your purpose. Alright, so I'm still going to leave it back at 6. Let me see 642 and see. And let me leave it back at 652. Yes. So you can see in this band that the river is dark and then the build-up is now blue. Alright, so now we've successfully subsetted. So the next thing on our syllabus is how to train pixels. Now, I'm going to explain something here, which one of our software we're going to be using is Google Earth. So we're going to use this to interchangeably to give us to have a better understanding of interpreting this imagery. Alright, so first I'm going to minimize this, then separate my screen into 2. So I'm going to divide my screen in 2 places. I'll do same with Google Earth. So I'm going to make the ERDAS imaging screen wider. So once you've joined this, you make sure you're connected to internet. All right, so you come to Google. If you do not see your Google, you just go to help and you type Google, it will still come. So as I search, Google will come. It found 7 results. So for those who did not see, but then you click on connect and then you click on match Google Earth to viewer. It's asking me to launch. All right, let it launch. Yes, then it's already syncing them together. So you now sync the Google Earth to view, so that it takes you exactly to this position where I am on the Landsat. You know, the Landsat is not as clear, but Google will give you an edge to look at what's on the ground, so that you can be able to effectively put out what you can do there. All right, so now you can see that as I move, the Google Earth image is also moving. So the next software we're bringing out is the Microsoft Excel. So we'll bring out the Excel so that we also take record of those data we're going to be using for accuracy assessment. But this video will not be covering accuracy assessment. All right, so I have videos that I made in 2018 on this same thing, but this time around making like an update, other things that were not included in those videos, probably due to my current level of knowledge as of that time. So this video is an update to that video. All right, so I'll drop the link to that video on this description, so you also check out that video. You will definitely learn 1 or 2 things there as well. So the next thing you're going to do here is want to train pixels. So you go to raster, and then you go, because you splitted the screen, everything will shrink. All right, so we have our classification, everything is under classification, and then under classification you go to supervise. Then under supervise you go to signature editor. So you have this out as your signature editor. This will enable you to pick out, as you pick out a sample, you will reference it here, so you will bring it here so that it could join those points together. All right, so you know raster uses pixels, so that pixels, the number of pixels it picks is those number that will be recorded here, and then you use to reference them at the end of the day. So after then you go to drawing. This drawing is where you're going to use these tools to make adjustment, to pick out those pixels. All right, so I'm going to use rectangle tool alongside any other tool that come to my mind. So if I zoom here very well, you'll see from the Google Earth that the entire thing that are here are built-ups. So I'm just going to make a selection, avoiding any pixel that has different colors. So I'm going to come here and create new signature, so it's going to be added. All right, so I'll pick another, this within this area, just sample them so that I'm careful not to infringe into other pixels. Okay, so now what I'll also be doing with the Excel is that I'm going to also create an easting, that I'm going to bring in their coordinate and then northern, because we'll be using it to then the number of class. Now this number of class, after your classification you have built up, we have a class name, have a class number, and BLN will have a class number. So the future will now be the name of those classes. All right, so the first 3 columns are what the accuracy assessment box uses. It doesn't, if you put futures before this, it will not show. All right, so I'm going to make sure that currently you can see that my coordinate system are on latitude, longitude. So I will go to tools, and then I'll go to options. Then I'm going to change it to UTM. Alright, so that's eastern and northern. So once that is done, I'm going to pick this tool here, this place mark. So from here I'm going to copy eastern of this place, knowing that it is a built up. I'm copying the eastern and I'm pasting it on the Excel. I'm going to copy the northerns and I'm pasting it as well. So I'm going to quickly first pick up about 5 samples for this, and then we'll move forward so that I don't have to be doing it all the time. So I'm going to pick out a few samples. So when it comes to your town, you should pick as much as possible you can. But for this video sake, I'm only going to use 5 classes. Alright, that's just to verify that the class you said it was, that pixel that you said it represented built up, should be built up. That's just what it will do at the end of the classification. 1, 2, 3, 4. So I have one more. So let me bring it down here. Okay, so we'll go back to this, and then we'll bring us, I'll also not take much classes here as well, so that we could have enough time. So you take your time. I'm only doing this video for you to take your time and then look at how you can minimize the errors. So I'm trying not to go to any pixels that do not demonstrate building. I'm just trying to look at it commiserable with the calculate. So you see, I don't know, you see that there are built vegetations around this built up. So I'm trying to not infringe. You can see them around here though, but then I'm trying not to infringe into other classes. That's why you see I'm using Google Earth to help me understand. So I'm only going to pick a few more, and then we will move to another class. Now you can see those that are having a bit of different colors. You see, this major, some of the mistakes that will happen when you're doing this. So you try your best to avoid them. Most of the times you have reflectance errors, so you try your best to do what you can. As far as you have an accuracy result of 70 above, scientifically it is approved for use. So once you have a result of 70%, you're good to go. So I don't know how the remote sensing association around the world can find a way of solving some of these algorithm issues and then the reflectance mixtures. So, but then you could read more about signature mixture, reflectant mixture, something of that nature. So if you have a better understanding about the signature mixture, the reflectant mixture, you could also drop us a comment on this video so that we also could learn more from it. So let me just go with what I've picked here. So you highlight from up, down, and you hold the shift button, highlight the rest. So we have 13 class we've picked. You come down to this merge selected future signatures. So you click on it. It's going to merge everything. Then you right click on this one and delete selection. You'll be left with this. So this will be now our build up. So you also select the color you want the build up to carry. So let's say I want to go with red for build up. So now I'm going to save this in case of any crashed in system or program malfunction or all that. So I'm going to say no to this. So I'm just going to go up here. So I'm go back. So this time around I'm going to create a place. I'm going to create another folder. I'm going to name it signature. Or I will just say train pixels. I'm going to OK it, and then here I'm going to say 2022. This is in time of when you're doing time temporal analysis, when you're doing time series analysis. So you need to distinguish all of this so that you don't get yourself mixed up. So next I'm going to be doing vegetation. So check to be sure that this is actually vegetation. Now in another case you could see that this can be a farmland, but then it depends on the study you're undergoing. If you're undergoing where you're trying to get agricultural land, but this is actually vegetation, not a farmland. Let's go further to be sure it's not a farmland. Yeah, these are vegetations, more like a thick vegetation, not really farmland. But then this band I'm using currently, it's more like a band that it's a very good band for understudying vegetation, agriculture, activities and all that. So you can see that it's correspond with what's on the ground, that we're on track picking out signature for vegetation. So I'm also going to do same for that. Since I said we're not going to be doing accuracy assessment in this video, so just like I've shown you how to do this, now you name the future build. We have built up, right? We have built up. So if you click here and drag this down, all will be named as built up. So now you will do the same thing for the whole class. Since this is not part of our scope, I'm just trying to use the medium to show you. I'm just going to pick signatures of all of this class so that we get our classification done. All right. So we'll look at this quickly. Let's be sure it is vegetation. Yes, it is. Sometimes I don't do anything without the help of Google Earth. All right. So it's helping us to verify what's on that ground. This will save you time. You know, in Abuja now, this will not be much of a problem because when we see it, we will know. But what if you go into a rural area, you're studying maybe a place like Kebbi? A friend of mine undergo a study there recently. He wasn't finding it easy. So when you're going to rural areas, it's become tougher. Okay, so I advise you always use Google Earth to help you in your study. So get the right ERDAS imaging. Some people are using version 9.2. Please upgrade. Upgrade to either 2014, 2015. This is 2022 I'm using. You can upgrade and get as higher. Alright, so when you're picking your pixels, be sure not to make errors. That's why we're using Google Earth. I'm always emphasizing this. Alright, so this is done for this. I think this should be enough. But you can pick as much as possible while you're undergoing yours. Alright, so we delete and then we name this vegetation. Alright. So what next? We have bare land. So this vegetation, I'm going to leave it as this, and then I'm saving it so that you also try to save your work all the time. So now we'll try to check on bare lands, where it looks like bare land. So let's zoom here and see it's actually bare land. But we're using Google Earth to always check these things out so that we don't make errors. All right. We're always verifying to minimize error. We cannot eliminate error, but we minimize it. Okay? So you're also bearing me witness that we're picking it well, right? So if this classification didn't go well, it means something is wrong, either from the image or maybe, we don't know, because you can bear witness that we're picking everything we can. So you see, this clears that it's a bare land, but you can see a few of vegetation here. So that's why I said always be careful when you're picking signatures. This video is going to be a long video, but it's going to be quite educative if you take your time. I know you don't like long videos. I'm taking my time to explain this because I know how I've been receiving different messages on my mail asking for how it's been done. I've done it before, some are more still confused, so I'm taking my time to explain. Alright? So do me proud by learning. And don't forget to subscribe to this YouTube channel. That will encourage me. I need more views, I need more subscribers. At least I'll be very happy if I see 10,000 subscribers after this video. And I'll be giving you back-to-back hits. Okay? So the previous video has like 20,000. So I want this one to be like 100,000. Can you promise me that? If you promise me that, I'll be giving you all the difficult video, I'll bring them, simplify them for you. So let's say I'm done with this. Okay, let me pick one more. So which side should I pick? If I pick anyone here, yeah. Okay. Let's pick from here. One more and then let's go to the final class. Like I said, you have to be utmost careful. You can see that I'm seeing some building here. It isn't showing that they are building, but now it's showing that there are buildings there. But then, I've said it before. Just try your best to do what you can. So we're going to delete this, and then this will be named as bare land. So I like using tan for this or beige. the beige or yellow light, any of them. That's what I like anyway, not that I have any cartographic form of doing that. So the next we're going to be doing, which is the last class, will be our water body. Alright, so I'm going to pick this tool and then we are going to hit. This is the Jabi Lake. And then I'm going to hit, so you see that it's showing as the Jabi Lake here. So do we have any other water body around? Let's check. Let's check to be sure that there's no any water body around. I don't think we have this in our study area. Let's check what this is. That's not water body, that's actually mountain. But we're not really considering that now, so it's going to be among the on class. So let's check whether this is what now. This looks like a water body, but let's check it out. It is not. It's a rock. Alright, so I think we only have one water body, though there are few rivers around the study area. So since that is the case, we will just save this as water body. Is that okay? Then we change it to blue, we save it. Now that we've saved it, we've done all our 4 class. Alright, so with the help of Google Earth, we've been able to train these pixels within the shortest time possible. So now what we'll do is we're going to be doing classification. I think that's what we have as the final thing on our syllabus. How to perform supervised classification. Okay, we could do that in 2 ways. From this, our signature editor, we could perform supervised classification, or we go back to raster and we can still perform supervised classification. So once I click on raster and click on classification and then supervised classification, I'm going to click on supervised classification. That is one. So dialog box will be open, which is will still put us back to the same place. Alright, so but then the advantage of doing it here is that I don't need to bring in the image and then the signature file. So I'll cancel this. Now from here I'm going to, you see classify here, I'm click on classify and then I'm going to supervised. Now this time around, all is asking me is the output file, that's the classified file. Okay, so I'm going to go to subset, and then I'm also going to go back and I'll create a new folder and I'm going to name it class as classification. Okay, so the folder has been created, so I'm going to still name it Amac classification. You and I know it's a supervised classification, so no need for saying it's a supervised classification. So I'm going to OK. Now here is where I was telling you we will use it in the future. You remember when I removed that AOI? So we'll bring it this time around. We're going to click on the AOI file because it's currently not here. So I'm going to select the folder to go to where it is, and then I'm going to subset. I think that's where we kept it, and then we have Amac AOI. So I will bring it in. Now what this implies is that it's only going to classify this without adding any other extra, so that if I'm calculating the area, there won't be excesses in the area. It's just going to do the classification subject to this class. I just this definition of the area of interest I just added. So I'm going to click on OK. Now you could choose any of these non-parametric rules, whether to parallel, elapse or future, but I'm not going to do any of that now since it's already on maximal likelihood. So I'm just going to click on OK and wait for result. So from here it's saying that the classification is done, so I'm going to dismiss and I'm going to close. So I'm just going to go to file and then I'll bring in Amac classification. So let's look at how it is, whether what we've done really makes sense or not. So for now I'm just going to open here, so we'll zoom and see whether our classification is actually correct. So you can see that virtually we have a neat classification. If we peradventure do an accuracy assessment of this, I'm sure we're going to have at least an 80% accurate result, at least an 80%. So this will help you to achieve a higher resolution of the result, higher accuracy in your result. So if you come to the original image, you will see that what we've classified really actually suits what we have on this. So now the last thing we're going to do for this video is to calculate the area. So to calculate area, you go to table and then you show attributes. Yes, you click on show attribute again, and then now area will be shown on this place. You can also add rows, you can add, you can do some editing, but then what we're interested in this video is to add area. So once I click on area, they're asking you what unit do you want it on. You want it on hectares, or you want it on acres or square mile. In Nigeria we use hectares, we use the metric system. So I click on OK, and then by the time you go to water body, you will see the area of water body and the rest. So let's look at their number of class now. Water body carry number 1. So once you are filling in this your attribute, water body will carry this number of the number, future number is that this one will carry its number. Water body has 1, but because we didn't fill everything, so that's why we don't have. But then let's check the one of the build up we've had so far. Build up has number 14, so here will be now your number 14. All of the build up will be, the number of the class will be 14. Alright, then any other one, as you see their numbers, you change their number to, so the area of this will be what now? Let's check its areas. So build up have over 54545 hectares, sorry. So when we go down, we'll check other classes. We've seen vegetation number 12, build up number 14, and which other one? Have you seen water body? Yes, number 1. Okay, number 9, bare lands. So all their areas have been added. Bare land has over 69,898 hectares. So number 12, which is our vegetation, has 33,986. So by the time you finalize, you see that we don't have any excesses here. Everything we have is based on the classification. But one more problem I noticed is that this lake, Jabi Lake, it has some small extensions of rivers, but then this extension of rivers have been converted into a built-up. So this issue has been a general issue over time, but then you keep trying your best to master the act. So that brings us to the end of today's video. Welcome to November. I remain your instructor, RIMAMFENTEN SHAMAKI, and you'll be seeing more of me in November compared to the previous month due to other busy schedules I have. So do not forget to subscribe to this YouTube channel and like the video, share this video, let it go as far end of the earth. I appreciate you and I love you for always tuning in and checking on us. So see you in class tomorrow. For me, and now it's bye bye.